In this lecture, we are going to take the first step in designing our collection type, which is going to be called the box container, to mean that it is going to be containing things or wrapping a collection of things, and it is really like a box you can store things in. This is why I chose this name here. We are going to see a bunch of constructors we can set up. We are also going to see a destructor. And let's look at some code here. We have a class which is our box container class. It is going to be inheriting from our stream insertable interface we have seen in our chapter on polymorphism. But if you want, you can set up an explicit output stream operator at this level in the class. That's also going to work. The whole point of setting this up is to make it easy to set up an output stream operator. This is going to force us to override the stream insert member function or virtual function here. So this is going to be an override. We should really say that here. And in this override, we will specify how we want our collection to be printed out to stdc out. This is what we're going to achieve here. We also have a constructor which is going to be taking the default capacity, and we have a copy constructor which we are going to use to construct a box container from another already existing box container. Let's look at the member variables we have here. We have a pointer to our type that we are storing in this collection. And we are making this a little bit convoluted because we want the flexibility to store different types in. So we can just copy this class and change this type def to a double, for example. And this is going to be a collection that can store doubles. And we don't need to change a thing about this class. We can reuse the code here. We are going to have a chance to see this later in the chapter. Down here, you see we have a static constant, which is going to be modeling the default capacity for our collection here. By default, we are going to be storing in 30 elements, but we can change this however we want. If you want, you can make this 100, 200. You can really use whatever you want. And this is going to be the default capacity we have in our box container. We also have a member variable to model the capacity. You saw that the capacity was the total number of slots we have in our collection. So we are going to model that here. And the size represents the current number of elements we have in our box container. This is the setup we are going to do. And once we have these member variables, we can set up a bunch of member functions to return them if we need this. This is what we are doing here. Now that you know this, we are going to head over to Visual Studio Code and play with this a little more and really set up these things. Here we are in our working folder. The current project is constructing and destroying. This is what we want to do. We want to set up our class and be able to construct and destroy box container objects. We are going to grab our template files. So let's do this. Let's copy and put them in place. And we are going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us a good starting point. But I think we should also bring in the files that are going to model our class. Let's put them in because that's going to save us the time to set them up. They are going to show up in Visual Studio Code. If you want, you can grab these files from the resource section on this lecture. You are going to be able to download them and look at them to save on some typing time. The first thing we have is our stream insertable interface. This is something we did in the chapter on polymorphism. So if we open up our code and go in our chapter on polymorphism, we can do that. The chapter is right here. And the last project was abstract classes as interfaces. In that lecture, we did a stream insertable interface that would be usable to print out all kinds of crazy objects. So we are going to reuse that here. Let's go back to the current chapter and current project so that we are really not confused. So this is our thing. This is our interface. It is going to set up a pure virtual function. And this pure virtual function will be overridden by whoever is attaching this interface to themselves. And we are going to be using the stream insert override to print things out. Let's look at our box container class. It is going to be including our interface. We are going to be attaching the interface to our class here by publicly inheriting from the interface. And we are going to set up a type alias to mean that we want to store integers in our collection here. And this is going to allow us to use value type, the type alias, to really mean that this is the type we are storing in our collection here. In this case, this is going to be an int. You see that this is modeled as an int. And this is basically going to be the same as saying int pointer m items. We are going to set up size t variable to store the capacity, a size t variable or member variable to model our size. And on top here, we have a bunch of constructors. The first one is going to be a constructor that takes a parameter, which is going to be our capacity. The default is going to be 30, and this is how we model this. And we are also going to have a copy constructor, which we are going to be using to build a box container object from another already existing box container object. Notice that we have our stream insert virtual function overridden here, and we should really go down and make it super clear that we are overriding an upstream virtual function. This is much more cleaner, and it is going to make our intent very clear. Anybody looking at this signature here is going to know that we are overriding a method coming from upstream classes that we are inheriting from. We also have a bunch of getters. This is going to return the size, and this is going to return the capacity. Let's look at our CPP file. The constructor is not going to do anything crazy. It is just going to initialize our pointer to set up a dynamic array to store our things. We are going to be using our default capacity here. If we go back to the header, we are going to see our default capacity here, which is going to be passed in. This is how we can set this up. After we dynamically allocate for this, we are going to set up our capacity member variable. This is going to be the capacity we pass in here, and the size of our box container object is going to be 0 by default. So we will need a mechanism to add elements in, and we can achieve that by setting up a dummy function to initialize our collection with data. We are going to be looping, for example, 10 times and storing in elements, and this is going to put in the data. And after we do this, we are going to say that our size is 10 because we just put in 10 elements here. Let's go back to the CPP file and look at the copy constructor. If you forgot, the role of a copy constructor is to allow us to build objects from other already existing objects. And the syntax is what you see here. The other parameter is going to be passed by const reference. And this is something you need to do. If you don't do this, you're going to have problems. And if you need more details on this, please go back on the chapter on classes. We had a chance to see why we need to pass our parameter by reference here. In the body, we are not going to do anything crazy. We are just going to initialize our array, and we are going to be reusing the capacity from our source object here. This is what we do on line 14 here. We are going to set up our capacity. Again, it is going to be the capacity of the source object. That's what we are doing here. And the size is going to be the size from the source object. After we set up our data here in our current object, we are going to copy the data from source. So we are going to loop size times, and we are going to be copying elements from source and storing them in our current collection here. And remember that our collection is wrapping around a dynamic array. That's why we are able to use the array index syntax here to put in data. We also have a destructor down below, which is going to just release the data from our array. And our stream insert method is just going to specify which data we want to print if we print our box container, and how that data is going to be formatted. And we're going to be printing this data on our output stream object here. So we are going to say box container, we are going to put the size out. We are also going to put the capacity out, and we are going to say which items we have in this collection. We are going to loop m size times and print each element out. And after, we are going to put our closing square bracket here. This is really what we are going to do to set up our box container class. Once we have this in place, we can head over to the main CPP file and try to use this. So let's do this. We are going to include the class. Let's include box container. We have this in, and we are going to set up some box objects. So let's do that. We are going to have a box one, which is going to be dummy initialized to some data. And we are going to print this out. So box one is going to be printed out. We're going to be printing its address in memory. And we are going to be trying to use our copy constructor to make sure it is working. And we will be constructing box 2 by using box 1, an already existing and constructed object. So let's try and run this code. Hopefully you see what we are going to get from this, let's go back and look at our dummy initialize method. It is going to be adding 12 to whatever index we have. So for index 0, we're going to get a 12. For index 1, we are going to get a 13, and we will keep going until we hit 10 elements. This is what we are going to get. So we are going to see 12, 13, 14 printed out if we print this guy here. Let's try and run this. We're going to build with GCC, our favorite compiler. The build is going to be good as you see here, and we can bring up a PowerShell window to play with us. We are going to run Rooster, and we will see that box 1 contains the data. The size is 10. This is what we expect. The capacity is 30. This is our default capacity. And the elements we have in are from 12 all the way to 21. 10 elements in total. We are going to see that box 1 is living at this address in memory. So box container 2 is going to be constructed from box 1. The data is going to be exactly the same because we are copy constructing from box 1. But box 2 will be a completely separate object living at a different address in memory, as we can see here. So this is something we just achieved by setting up this box container class. We have a bunch of constructors. The default constructor is working here. And we can do this because we have a default argument for the capacity for our constructor here. Let's go up and show you that. So if we don't specify any parameters, this constructor here is going to be enabled, and it is going to pass down the default capacity. That's why we have a 30 here. Hopefully this is not confusing to you. We can also explicitly pass the capacity if we want. For example, we can say 15. And if we build our program, let's do that. We're going to run the task to build with GCC. We should see a capacity of 15 if we run again. And our capacity now is going to be 15, and we are going to have in the same data. Nothing confusing here. We have a copy constructor. We just tested this out. And we have an output stream operator, which is working to print our box container objects. And it is working because of this stream insertable interface that we are attaching to our box container object, and we specified how we want the data to be printed out through our stream insert method here, which is an override of the pure virtual function we have from our stream insertable interface. It is right here. It is a pure virtual function. This is really all I had to share in this lecture, showing you how we can construct box container object, how we can destroy them, and really how to set up a basic foundation on top of which we will be building everything we are going to do in the remainder of this chapter. We are going to stop here in this lecture. In the next one, we are going to show you how you can actually add elements to this collection and not have to use our dummy initialize method here and make things much more flexible. Go ahead and finish up here and meet me there.